So three things you need to understand. One is the state, what is the time period for that state, and what is the performance that we are going to measure. So that is an indicator, period of admission over the reoccurrence of the particular disease, or gives us the power to measure many hidden and deep performance things. To optimize the profits, they need to optimize the schedule first. And creating a pivot table with Heatmap. This is the analysis, data migration strategies, and migrating the data for small medium business. All right, so in this video we are going to discuss about cohort analysis using BigQuery. Cohort analysis using BigQuery. Right. Cohort analysis is more like a behavioral analysis required and essential for many business scenarios where we segregate or we segment the stakeholders, the business users, the people, or any business entity into some groups of certain characteristic over a period of time, like some state what they have achieved in a specific period of time, and over a period of time how these groups are varying in their performance of a specific of a specific value to business, how their value to the business is varying in the subsequent periods of time. Okay, so the first thing what we need to understand in cohort analysis is about what is that characteristic we are considering it in order to form a group. Okay, so and then we divide that groups across a certain period of time on that. So three things you need to understand. One is the state, which state are we considering it for the analysis, and what is the time period for that state, and what is the metric and what is the performance that we are going to measure about that particular group over the subsequent periods of time. So these three things are important for us to understand cohort analysis. So that will give a brief understanding from the use cases. Take for example, if you're considering a hospital, an hospital here, so the number of patients admitted in a specific month, right? So this can be over a period of time, that means months could be one cohort. So that means the patients admitted in January, the patients admitted in February, patients admitted in March, like that. So you divide this particular state, that means admitting to the hospital is one state. So this how many one group of people who got admitted to hospital in the month of January will be one cohort, that is cohort 1, right? So like that the group of people who got admitted to hospital in February will be the second cohort, that is cohort 2, right? And how many these are and readmissions and consults are the performance indicators which the business wants to measure on these individual cohorts, right? So out of the people who got admitted in January, how many readmissions are happening in the subsequent periods of time, that means the next month, that means in February or March or April, up to the next maybe 12 months, how many people are getting readmitted from this cohort. Likewise, from this cohort, how many people are getting readmitted in the subsequent month period, means this is the cohort who got admitted to hospital in the month of February, so the subsequent month is March, April, May, like that. So this is the performance indicator the business wants to measure, like that. How many people are getting visiting the hospital for consultations. So that is an indicator which says that is there any influence of the period of admission over the reoccurrence of the particular disease or particular ailment. Okay, So this gives an indication to the business saying, uh, so what additional care we need to take if in a people who got admitted in a particular month are having more number of readmissions. So there could be some correlation between the period, the initial period of treatment versus the subsequent reoccurrence of disease in the subsequent months. So this is an indicator, and where the business strategies can be validated. So some business strategies can be validated, and the operational efficiency. So these are all the various interests of business in order to make their operations more efficient, and also to understand what exactly are indicating the performance of a particular business entity. Here the performance factors, are they related to time, or are they related to the equipment or staff, or the time is also one of the hidden variable which indicates the performance of a particular business unit. Okay, so likewise we can understand that cohort analysis in terms of if your business is about providing a telecom service or any network service, your ISPs. So how many new installations have happened in a particular week, and subsequently, so here our cohorts are installations happen in week 1, week 2, week 3, like that, over a period of over some range, for around 12 weeks you want to study the behavior of the installations. So how many new installations means new customers have joined the business, and then among the people who joined, who got the installations done in the first week, how many network issues did they raise, and how many of them have dropped out of business, or terminated their connections. And over the next 12 weeks that we need to study on that. So that gives an indication saying that what is the influence, influence, uh, or the significance of the installation that has happened in a particular week. For example, if you say that on week 4 around 100 installations have happened, out of that there are around 30% disconnections, they terminated the connection in week 5 and 6 of that. So that indicates that there is some problem in particular cabling or networking in this particular week, or maybe some weather conditions, or the staff who attended that. There could be a number of reasons. Those can be quickly validated by business and take corrective action on that. Right. So similarly, in a retail store, if you say that we have new customers, you're running some offers and some campaigns every day on a retail store, offline retail store, and you're getting new memberships every day, and the data can be organized. The sales data of a particular month can be organized, and see that how many people who joined or who took the membership on a particular day, from 1 to 31. So the month, on a particular month sales data you can take and see that people who joined in the first day, how many have reoccurred, how many have purchased again, how many have visited the store again in their subsequent periods of time, that means the next days. On their second day, third day, fourth day, how many of them have visited the store again and purchased something, at least one item from the store again, and how much amount of time that they are spending it. This is another analysis. This is one type of analysis, saying that measuring the retention of a customer, and then measuring the how much money that they have spent, maybe how much time that they have spent on the time. So it all depends upon the sales data what you have. Take the data and then first divide them into cohorts, and then start analyzing their behavior in the subsequent time periods. So this is what, in short, what the cohort analysis means, and what value that it adds to business on that. Now BigQuery. So why do we need BigQuery? BigQuery it's almost like an infinite table, infinite amount of data that we can store, and we can still feel that as a SQL, as a structured data on that. And BigQuery has now become very popular in warehousing technology, where you can you can store this sales transactions in any raw data form, but you can just import that into by using the connectors. You can import that into a very big and large infinite table on that. So now the BigQuery provides the SQL syntax. By using almost similar to SQL syntax, you can quickly query this data at a fastening speed. So whatever, even in GBs and in millions of records, what we have it, so we can quickly query that one and create by using a standard SQL queries here. So this provides the combination of these two technologies, like one is the methodology of doing cohort analysis or the behavior analysis, and the ability for us to do this on a larger scale of transactional data gives us the power to measure many hidden and deep performance things, like which require some complex formulae to understand the performance. So here it's oversimplified. I mean, the retention and spend and these are oversimplified. But when we combine this with the emerging technology, I mean the latest technologies like BigQuery, that gives the business the power to measure the behaviors that involves complex logics as well. Okay. So that is where we are going to see how we can do this on with some real data on that, with some data set. So I'll explain one of our projects first. Let's get on to the project case. One of our clients is a taxi provider. He's a taxi service provider. Right. So a client is a taxi service provider over on major cities in Asia, and they provide the taxis around the clock. I mean, each taxi, yeah, they have several taxis in hundreds and thousands on that, and each taxi is owned by a particular driver, and they run as per the shifts that are created by the client. They work in some shifts what the client designs or releases for them in a roster on that. And each taxi runs for around 8 to 9 hours in a day, but it all depends. The driver can take breaks in between, or they can extend their time as per their convenience or their affordability to work in a day on that. Right. So but what the client wants to know is that to optimize the profits, they need to optimize the schedule first. While maintaining the flexibility of the drivers, the organization need to maintain the fleet. They need to maintain the fleet as per the demand of the hour, as per the demand of this hour. So they need to know. Here the goal of this analysis, the behavioral analysis, is that by looking at a transactional data of a particular day, the client said that they want to know if there is any correlation between the time a driver starts their duty, his or her duty, and the number of hours they provide the service. While 8 to 9 hours is a mandatory duty hour, so they can extend the time. So some people will start and they work for 10 to 12 hours or 15 hours a day on that. Maybe in between they can take some breaks on that, right? So is there any correlation between the time that they start? That means the start time is the one which is provided in the schedule on that, and the number of hours that they are actually delivering the service. So if they come to know about that, and based upon that, the client wants to make more proactive schedules so that the fleet management is done more accurately, and more taxis will be available to the passengers at peak hours of time, and also the flexibility is maintained to the driver. So there are so many business relations involved on that one. So for coming back to our definition, like the state at the time period and subsequent time, the performance at subsequent time period. So here the state is that the start time. The start time is when the duty has started for in a day, starting from midnight. So midnight 0 hour, maybe we can call it as 12 a.m. To 23rd hour to 23rd hour. So when did a particular driver start his or her duty on that? That's the start time in particular hour. So these are all the cohorts, 24 cohorts that we need to have in this analysis on that. And then the performance is that here the performance indicator is had they delivered the service or not. Even if you deliver at least one ride in that hour, so we consider that the taxi is made available. If the person has not delivered any service, that means that there is no transaction record of that particular taxi in our sales data, in our transactional data. Then we say that either the driver is taking the break, or we can consider that the driver is unavailable at that point. So the performance indicator is, did the taxi been used or booked or on a particular hour. So that is our performance indicator. So for every cohort, so cohort 1, so where the start time is 12 a.m. okay, and subsequent hours 1, 2, 1 a.m., 2 a.m. till 11 p.m. So how many people have started at 12 a.m. and how many people have out of these taxis, how many are available at each hour of the day. So that is what the cohort analysis that the client wants to do on that based. Now I'll explain how this can be done using BigQuery on that. So we need to use BigQuery because their entire transaction and their entire total warehousing system has been brought into BigQuery, and they do not want to connect the client. Here also the challenge is that they do not want to connect any APIs or pull the data out, because it's a very large data that keeps on keeps generating hour on hour. So they don't want to pull this data to some other location to just for doing this particular analysis on that. So is there any way that we can do this analysis directly in BigQuery itself by using some SQL statements? So that would be the best and the ideal approach, not to move the data so frequently on that. So we did some research and found that it can, by putting this algorithm and data organization, can be done more pretty simple, even by using the simple SQL queries on that. Okay, so let's get now I'll try to demonstrate this by by using some public data on that. Obviously we cannot use any client's information or data in this demonstration. So let me get to the BigQuery, and I'll explain you how we can do this cohort analysis by using some public data on that. Right. So this is the project that I had created, D247350818. So in this project that I am referring to the public data set, as I mentioned here, the public data set that we are going to consider for this demonstration is BigQuery public data, Chicago taxi trips, and we have this public data set available here. Let me see this. Okay, so there is some data available here. So this comprises of several fields with respect to one particular taxi booking. There is a unique key, the taxi ID, the start time of the trip and time in trip seconds, and so much of information available about a particular trip for several days on that. So the first thing I'm going to do, as said, the goal of this total analysis is to find if there is any correlation between the start time of the trip and the number of trips that a particular taxi has made in on a day. So that is our core analysis and the objective of our behavioral analysis we're going to do. So for that, so my first my approach is that first take this two fields. These are the only two things which are required for us for our analysis: taxi ID and taxi start timestamp. So this is what the taxi ID and trip start. So let me take that into data. I have created one data set here, the cohort analysis data set. Now I just want to take that information for a particular day, so the 1st April. So during this time, so on where the trip start, I'm taking only subset of the data for demonstration purpose. For example, this involves so many, how many? Count 1, 2, 3. Okay. So many records here. So let me take this. Okay. So let me execute this one, this query, which brings this creates one subset of this taxi trips record here. Taxi trips record data. This contains around 19,000 transactions have happened on 1st of April. Right. So this is our base data for our analysis. From here, so this is done. So this particular thing is done. Now I want to create one staging table, so that takes only transaction hour. So this, let's calculate the transaction hour from this start time, from this trip start timestamp. I want to take only the transaction hour. So what is the transaction hour here? So I'm going here. My next query I'm going to run here is that create or replace table here. Select this extract the hour from this timestamp, from the start timestamp. So and call this as transaction hour. So extract hour from timestamp, time zone as UTC. UTC is a time zone what this dataset comprises of. So now I'm executing this particular thing. Now I will get one. I got one staging table here, so that contains two columns here, the timestamp and the transaction hour. So here it says this is 0th hour starting on. So let me show you this. So this is 23rd, means 20 this hour. Okay, you can show you the timestamp hour. So even here, so 23:15, it's a transaction hour is 23. Like that, we are able to calculate the transaction hour. So like in parallel, this is done, the transaction hour is done. In parallel, let's calculate what is the earliest from this, from S1 we need to calculate. Let me calculate one more the staging table that gets the earliest transaction hour for each taxi. So because that is the group, that is a criterion for us to create the group. The criterion is that when did each taxi start the trip on that day. So in this 19,000, so there are one taxi might have made several trips on that. So what is the earliest time that taxi has started on a particular day? So that is my next query, and I'm creating one more staging table here. Okay. So what it says is that taxi, we are taking a minimum of transaction hour, and then we are grouping it by transaction ID. Okay, so that gives the staging table 2. So there are 1764 out of S1 has around 19,000 transactions have happened, but out from by 1764 taxis. So these are the number of taxis here. 1764 is the number of unique taxis operated on that day. Which day? The 1st of April. And this is the start hour for each taxi. So for this taxi, the start hour is 0th hour. That means 12 a.m. So like that, for this taxi, the start hour is 20 hours. So this taxi made its first trip at 8 p.m. That is what it says. Now we got these two. Got transaction hour, and here I got the earliest transaction hour for each taxi. By joining these two, so now we are going to get the transaction hour, the start hour, and the transaction hour for each transaction that has happened on that day, for each taxi, and that is the 19,000 records. When we join these two, let me join these two again. So, and create one more staging table there. So let me join these two and left join by taxi ID and create. See how fast the query is running. The same, almost the speed will be similar, even if the data is huge. I mean, even if it's not a subset, if you are working on the total data set, probably that will get into the same speed, similar speed. Now S3, we want taxi ID plus when did it start and what is the current transaction hour. So for this taxi ID, this transaction has happened. There is a transaction in the 14th hour, and for this taxi ID there is a transaction on 14th hour. And when did this taxi started working? Started working from the 0th hour. So let's go back and see some points here. Right. So this taxi has a transaction at 23rd hour, but this taxi has started working from 19th hour only, not from the morning. It started working from 7 p.m. around. And this transaction indicates, this record indicates that this taxi has some transaction at hour 23. So like that, we got for all 19,000 transactions, we got what is the starting hour of the taxi, and also is there a transaction in a particular hour or not. Now we need to bring the cohort index. Cohort index means that the subsequent time period. It is not the absolute time period what we are measuring for each group. The subsequent time period. That means if a taxi has started at 7 p.m., its subsequent hour, its cohort index of 8 p.m. is 1. Its cohort index 1 means it is 8 p.m. For a taxi that has started at 5 p.m., 8 p.m. means 6, 7, 8. Cohort index 3. That means 5 p.m. plus 3 is 8 p.m. So cohort index means we need to represent this transaction hour in terms of starting hour. So that is what the cohort index is. How to express starting hour, transaction hour in terms of start hour. So for that, let's get into another query. So we are simply saying cohort index, defining cohort index as transaction hour minus start hour. Very simple. So this has given us S4 that contains the taxi ID, the trip, the timestamp, the transaction hour, the start hour, and the cohort index. Cohort index means what is this transaction hour in terms of start hour. So it is 0, so you will not find the difference. If I go here, yeah, so we have some cases. Good. So for this taxi, the transaction is 23rd hour, and it started at 7 p.m. It is 19. Start hour is 19. So its cohort index for this transaction is, if you express its transaction hour in terms of the start hour, the cohort index is 4. So what it is 4. So in the 4th hour for this taxi, there is a transaction in the 4th hour. For this taxi, there is a transaction in the first subsequent hour. So that is how we were able to now express the same transaction log like this, where the taxi ID, the start hour, and the cohort index. Now let's take the subset of this, and now let's group by taxi ID. Group by the cohort index and the start hour. For each combination of start hour and cohort index, how many taxes are there in that group? So our cohort here is the start hour, right? The start hour means the tax is our time. If you go back, so what we are trying to achieve here is that this one, state a time period, when did it start, and the hour, the start hour. That is our group means our cohort. So this is where let's group this by start hour and find how many taxi counts are there for each cohort index on that. Okay, this is my query for that. Is this there? Yeah, of course. I think this is the last query we had. Control E. So when I do that, I get one more table here. So that comprises only 3. So what is a start hour? For this start hour and for with this cohort index, there are 135 taxes which started. This tells the complete story. This table tells the story. There are 135 taxes who started at 0th hour and had some transactions during this hour, 23rd hour. Like that, there are around 15 taxes that started at 1st hour and they had some transaction during that particular subsequent hour. Subsequent hour of 1 is at 1 p.m. So let me tell what this story tells is. So what this record tells. This record tells there are 41 taxes which started at 13th hour and had at least one transaction during the 5th subsequent hour. That means it is 1 p.m. 5th subsequent hour is 2, 3, 4, 5, 6 on 6 p.m. During 6 p.m. At 6 p.m. they had transactions, at least one transaction at 6 p.m. That is, there are around 41 taxes like that. So this is the base data for us to create the heat map. Now that, so right, so this table also we have created on. Okay, so now what we need to do is we just have to explore this particular data using our using our Datastudio. So when we explore this by using Datastudio, so the same table, Google Datastudio, connecting this S5 table and creating a pivot table with heat map. This is the analysis what we get it on. So here we are taking the row dimension as start hour and the column dimension as cohort index and the taxi count as the metric, the performance metric what we need to measure on. So and we are sorting them by row and column. So we get at 12 a.m. there are 282 taxes whose start hour is 12 a.m. Out of these 282 taxes, the 140 operated in the first hour. There are 82 taxes that are operated at least in the second hour, and this provides the behavior of each taxes. At 4 a.m. only 35 taxes have started their work at 4 a.m. and they had subsequent hour in the 5 a.m., 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m. At 10 a.m. only 18 were operational by that time. Out of 35, only 18 were operational by 10 a.m. So other people, maybe they don't have the business or they are just taking rest. They took some break. Right. So and this indicates some good information for us. And here the things are blank because we took the data only for one day, for 24 hours a day. So if you had you taken the data for 48 hours, then we will get the data for these groups as well, these cells as well. So the taxes which started their work at 8 p.m. only 10 taxes started their work at 8 p.m. That means they did not, which had no transaction till 7 p.m. They started their work at 8 p.m. and at 9, 10 and at 11 only 4 are operational at 11. Right, so that means that they are not completely on duty, so only partially that they have are available at that point. So this is something of interest for business to see why they are not working at full capacity even at 10 p.m. on that, why they got retired at 8. Okay, and of course they need to be available for a little more time on that. Okay, right, 9, 10, 11, 9, 10, 11, 9, 10, 11, right. Okay, now let's get back and see the major findings what we got to our client, similar to the analysis what we did on Chicago data. So the taxes starting at 4 a.m. For 5 hours there are more than 50% operating. So if we take this, let's see what these are some of our findings. In fact, taxes starting at 4 a.m. So for 5 hours they have more than 50% are operating. That means that, so if we take this data, 35 for 5 hours, 1 2 3 4 5, 25 are operating on that. More than 50%. 50% means around 16, 17 or 18, and they are consistently available. More than 50% are consistently available, so the business can rely on that. But after that there is a decline in their availability on that. Now, but if they are the taxes which started at 6 a.m. For 9 hours more than 50% are operating. If there are some taxes starting at 9 a.m. 135 taxes, and for 9 hours consistently it is above 70. Consistently above 70 are available for 9 hours on that. That means the drivers, the chauffeurs here are more productive. I mean the fleet here is more productive, saying more availability is there if they start. Maybe they're more energetic or more demand is there. They're meeting that, and from after 9 hours the availability started declining it on. And if the team is starting at 3 p.m. so, and there are only 5 hours, only for 5 hours they're occupational at 3 p.m. If you look at the cohort that is starting at 3 p.m. the 47 has started. Okay, and they started declining, and there is steep declining here, 15, 21, 10 immediately after 5 hours. So this is something of concern to the business. If 47 people are asked to start at 3 p.m. and why only 15 are available at what time? 3, 4, 5, 6, 7, 8, 9 p.m. till 9. At 9 p.m. business is, they're contributing only 15 taxes to the 9 p.m. business. Something the business can take a look into that. At 5 p.m. only 2 hours that they're available, and there is a decline in the availability of these taxes. So the roster has to be made more effectively in case if they want to make most of their fleet available to the business on that. and so many analysis and some derivations we can bring from there. The taxes starting at 1 p.m. are very consistent in operations for 8 hours. Similarly, the starting at 1 p.m. are more consistent. So right here, perfect, that's a good observation. See here, so they are very very consistent, even though the demand is around 70% of their core capacity, but they are consistently available. So more predictable. For 7 hours they are predictable, saying that you will get some business for at least 40 taxes. If you have a fleet starting at 1 p.m., so you'll get at least a consistent business for 7 hours. They are occupied. The occupation percentage is more. And those starting at 2 p.m. have many fluctuations, but for the taxes just starting at 2 p.m., so there are so many indicators. It's not only about the route they are taking, but also the time is also a factor happening here. There's a lot of fluctuation for the taxes just starting at 2 p.m. So it's 25, 20, 31, and then coming down to 15, 13 again increasing. So there is some fluctuation here. So we can find out the reasons for that. Is it because of the lunch hour or break or whatever, the traffic conditions, what it's making these taxes to. But during the same time, the other fleet has a consistent performance. Why the fleet starting at 2 p.m. is showing some fluctuation here in the availability. So this can be easily figured out by business and take some corrective action on that. So that completes. So what it says, what we are trying to do is more about finding the things and looking at how this cohort analysis can understand the behavior of various taxes and help the business in taking corrective action, they're validating and making their operationals on that. Okay, and especially by using BigQuery, so which is very effective, and you don't need, and for doing these analysis you don't require any APIs or any other connecting points here. You can simply do with simple SQL queries by just organizing. But thing is, you need to know the process of doing this cohort analysis, which we studied in detail in this video on that. Okay, so if you want access to this code, I think I can give that access by, if I know your email ID. So you just send your email ID to this for code access. So we are a team of data engineers, and so we're data engineers. We work 24/7, and it is easy to remember our email ID as well. Just say dataengineers247 at gmail.com, and we are accessible to you. And just send your email to this for any code access or for any business needs. And we are available. We have our presence at Upwork and LinkedIn as well. With our average experience of 15 years of programming experience we have as a team here, and we have very rich experience in creating this data migration strategies and migrating the data for small medium business of various domains, and we are the experts in creating the SQL queries on that. For any business, if you require in this area with BigQuery or any cloud-based migrations or data enrichments, please do reach out to us. It's dataengineers 247 at gmail.com. Right, and we can connect over likewise we can connect over LinkedIn or Upwork to get the things done. And especially for the code access, you just write to us, send your email ID so that I can add you here. Right, yeah, this is one. I can provide you the code access, and this is the email ID for you to reach out to us on that. dataengineers247 at gmail.com. I'll provide you the data access so that you can go through these queries and you can create your own data set, and you can play with this and tweak that. And do let us know if you require any modifications and customizations to be done to your data set, and we are happy to help you in that area. Right, so thank you very much for listening and joining this session. Hope this is more useful to you, and you can start leveraging the benefits of this BigQuery, especially the cohort analysis, which is very much essential, and make your drive your business in a more efficient operations and the strategies on that. Right. Thank you and have a good day. And please do write your comment how you feel about this session, and if you want to cover any new topics or technologies in this area, do let us know either through email or by writing the comment there. Okay? Right, good. Have a good day. Take care. Bye bye. Till we meet the next in the next video.